Hey class, today we're going to start Module 10, which is a module about estuary communities. I have posted the notes on our website under the resources tab in study aid. So if you don't have that yet, go ahead and pause and print and come back with that. Okay, so Module 10, estuary communities. That first word on your notes is estuary. All right. So what is an estuary exactly? An estuary is a semi-enclosed body of water where fresh water and salt water come together and mix. Okay, so it's a special type of community where you have these two very different bodies of water with different salinities mixing. Okay, you can think of it kind of like a water pathway inland from the ocean. There's fewer species that live here, but because they can't tolerate the differences as much. There's fewer species that live here than what we saw in the rocky intertidal, but it's still a very productive environment. Because of where estuaries are located on the coast, from the ocean up rivers, they tend to be places that have very large harbors. Industry is built along estuaries as well as cities. So cities are established there too, because of the potential for just trade and activity there. Okay. And so it is, it's agreed by most sciences that estuaries began when large quantities of ice melted at the end of the ice age, and this caused the sea levels to rise and move in to lower areas of land and also the mouths of rivers. And so that second blank on your page is Ice Age. All right. So an Ice Age is basically a period in Earth's history when the average temperature of the Earth was significantly cooler than it is now. All right. So during that time, you would have had glaciers, which are very large and thick sheets of ice that move across the land. So it's estimated that at one time up to a third of the Earth's surface was covered by these large sheets of ice. And as because they're so large and heavy, you would have this flow, this outward flow, just from the pressure of the ice on the glacier. You would sometimes have this flow, and as the glacier moved across the surface of the Earth, it would carve out the land and basically scour and scrape the land as it's moving. So it would pick up rocks and debris, sometimes big boulders, settlements, and as it moved across the land, it would carry these sediments, right, as it's going down to the lower latitude. And so as it's moving and carrying these sediments, it would also deposit sediments along the sides and along the front of the glacier as it's moving down. So those are called glacial deposits. All right. Glacial deposits are just where the glacier has deposited gravel, dirt, debris as it's melting and moving along to lower altitudes. All right. You can kind of see that in the picture over here to the side that I included, the glacier moving down to a lower latitude and depositing things along the side and along the front as it moves. So what is necessary for a glacier to form? All right, so you need a lot of you need a lot of snowfall. Okay, a lot of snowfall, but at the same time, you can't have much snow melting. If it's going to accumulate in large quantities and in thick sheets, it can't melt that quickly, right? So a lot of snowfall, but not much snow melting. You also need warmer oceans. Okay, this is necessary to have a higher rate of evaporation. If you're going to have a lot of snow falling, you need a lot of moisture in the air. And so by having warmer oceans, you have a higher rate of evaporation, which puts the moisture in the air that could turn into snow. You also need some pretty specific weather patterns occurring. during this time so that the moisture can be transported from the air that's over the ocean over the continents, where the glaciers will actually form. All right, so you have to have weather driving that moisture someplace else. And then the last thing under that section of conditions for glacier formation is cooler summers. Okay, this is necessary because you don't want the glaciers melting away, right? You want them to continuing to accumulate and getting thicker. And so the cooler summers are necessary to prevent the snow from melting. But you can't have winters that are super, super cold because cold air can't hold as much moisture as warm air. And you need a lot of moisture in the air for the snowfall. So it's very, very precise conditions that are necessary for a glacier to form. All right. And so, as we said, most scientists agree that estuaries then were formed by some type of ice age. So there's two scientific views out there when it comes to ice age and how long it took for things to form, as well as how this actually happened. So the first one is scientists called uniformitarians. Okay, uniformitarians. Okay, uniformitarians basically are scientists who believe that what we observe today on Earth is a result of really slow, gradual processes that act over a long, long period of time. You know, think evolution, millions of years, billions of years. And so it had to have, for them, it happened over a very slow period. So what they would believe is that there are several ice ages that have occurred over the years, over the many, many years, and each of them would have taken a long time to occur, with the most recent one starting about 1.75 million years ago up to about 18,000 years ago. So that would have been the most recent one. So this formation of the ice age over a gradual period of time is difficult for uniformitarians to explain. They can't really explain how all the processes happened over a long period of time, because to create an extremely slow rate of glaciation, it'd be necessary to have this constant flow of moisture from the ocean to the onshore area over tens of thousands of years. All right, so for the Earth to sustain that kind of condition is just hard to explain, right? So that's the first way to look at it or try to explain it. The second way is a group of scientists called catastrophists, okay, which basically believe that a lot of what we see on Earth today was formed by a big catastrophe in Earth's history. And so the geological features were a result of a wide scale catastrophe on the Earth. So they only believe in one major ice age that was brought about by the worldwide flood of Noah's time. And it would have happened very quickly, and it would have happened very recently, like, and so this actually is something that scientists would be able to explain. All right, so if you think about it, during the flood and right after Noah's flood, there would have been a lot of movement. Okay, this movement comes from the movement of the continental drift of the plates. There would be sediment being deposited and also being eroded away as a result of all that. Mountains would be built up as plates are settling and colliding into each other. So there's a lot of work being done, and that work would be translated into heat. All right, so all that movement could generate heat, right? And that then would cause the oceans to be warmer. Okay, so that's that one sentence there. All that movement after Noah's flood generates heat, which gives us the warmer temperatures in the ocean that we need. All right. The second thing is that the Earth's atmosphere would have had massive clouds full of particles, particulate matter in the air from volcanic action that's happening right after the flood. And so all of that particulate matter and aerosols in the air would have created these clouds that would have actually deflected the radiation coming from the sun, so that it's not fully reaching the earth, and that would have given us the cooler temperatures that we need on land and also during the summer. Okay. So that the snow's not melting so quickly. All right. And so these differences in the ocean temperatures being warmer and the land temperatures being so much cooler would have created the right conditions to have constant storms. And so these storms could be rainstorms, but they could also be snowstorms, like we're talking about a lot of moisture in the air and cooler conditions on land. And so all of that combined, the cool summers, the extra snowfall from these storms, could result in an ice age. For a period of time until the earth reached a certain equilibrium after the flood, right? Until everything settled down, we could have these conditions that are necessary to create an ice storm, an ice age, and that is much easier to explain than the uniformitarian view, right? And so why are we talking about the ice age again? It's because most scientists believe that estuaries were as a result of formed as a result of an ice age. All right, and so the rest of our time we're just going to talk a little bit about the 5 different types of estuaries. This is a pretty short chapter, so the notes today aren't very long, and we'll cover the rest of these notes when we return on the 26th. This is a pretty short chapter, but too much information for me to cover in one day. And so we probably won't have a quiz on this module. This will all just be included on your test for Module 10, which will be on March 5th. Okay. And so let's talk about these 5 types of estuaries. The first one, and so first of all, estuaries are grouped a couple of different ways by scientists. These categories that are in your book are grouped on their topology, their existing topology, like what they look like today. Some scientists will group them based on how they were formed geologically. And if we're looking at it that way, then this last one, the river delta, gets removed from the list, and it's just those first 4. But either way, they're all types of estuaries, so let's cover what they are. The first one is called a drowned river valley. Okay, so a drowned river valley, okay, is the first one. These are also called coastal plain estuaries because that's where they occur. All right, drowned river valleys. These are they started off as V-shaped, really deep, narrow river valleys, but after the ice age, when the ice began to melt and the ocean levels rose, the ocean moved in to these areas and flooded these river valleys and caused them to be wider and shallower along the edges. So they're still deeper in the middle, but the edges are wider and shallower, and that's a result of the ocean moving inward. After the ice age, everything melted and the ocean levels rose and water moved inward at the mouths of these rivers. All right, and so those are called drowned river valleys. All right, the second type is a tectonic estuary. Okay, this is a result of tectonic activity. We know that tectonic plates move and shift, and they can cause geologic structures. So a tectonic estuary is a result of this movement of the tectonic plates, bending and folding and cracking and creasing. Okay, but sometimes creating deep holes or basins And if that happens near the coastline, again, the basin could fill with oceanic water as a result of ice melting from the ice age. And so, if you kind of look, I have some examples of what these might look like over on the side, just a basic diagram. But these are a result of tectonic activity. All right. So the next one is called a bar built estuary. These are a result of, and they could be created by sandbars or barrier islands, but it's a result of fresh water flowing into an ocean but hitting a sandbar or a barrier island, which prevents this fresh water from pouring all out directly into the ocean. And so it's kind of concentrated there between the coast and the sandbar. So there's still oceanic water, still salt water, but this fresh water is kind of trapped right there where it comes into the ocean. So I'll go ahead and define this other term, a barrier island, which we have some off the coast of Georgia. But a barrier island is just really like a really humongous salt bar that's big enough that it stays constant and it has vegetation and trees and stuff like that growing on it. Okay. And so whether it's a sandbar or a barrier island, they can create a bar built estuary. All right. So the next type is a fjord. Okay, fjords are also deep river valleys that were created by the movement of glaciers. So the glaciers carved them out as they moved across the land, and they were carved out so deeply below sea level, then the rising coastal waters came and filled them in. Now, what's interesting about fjords is that because it's not being fed by a large river like some of these other things are that with a constant flow of fresh water coming in from a river, these are mostly being fed from the ocean. So the salinity of water in a fjord is going to be closer to that of the ocean water salinity. So you do still get fresh water coming in from rain and melted snow off of mountains coming down, but the salinity is going to be closer to that of the ocean, right? Because not as much fresh water is coming in. All right, and then the last type of estuary is called a river delta. All right, these get their name because it's where a river empties into the ocean, and as it is moving along, it's picking up sediment from the riverbed. All right, and so along the edges of the river and along the bottom, it's picking up sediment, and when it hits the ocean, it deposits all the sediment. Okay, and the shape of the deposit is kind of triangular, and that triangular shape is called a delta. It's kind of a fan-shaped triangular shape, and so it is deposited near the boundary where a river meets the sea, and it's shaped like a fan. So again, this is mostly fresh water from a river hitting ocean water, but they're unique in that they bring a lot of sediment to deposit when they reach the ocean. Okay, so that is it for your notes today. There's not a lab or anything that we'll do for this part, but when we meet the next time, we'll finish up the rest of the information for module 10, and we'll have a lab on that day. But again, I won't have a quiz for these notes. They'll just all be included on the module 10 test that I'll give to you when we meet again on February 6th. So just be working. Your assignments are posted under the announcement section on our website. The notes, you'll find them there on the website. And so I hope you all have a wonderful winter break, and I'll see you on February 26th.